says here next probe is minus 51.47. That's here. So why the hell do I not see an arrow here pointing to that place? Probably because of that. Oh, yeah, never mind. Should just print the values that it said. I mean, for now, since the drawing isn't really working, it seems. Yeah, I can just print it like this. That's wrong. I think I need this. Seven, 3, 3. Or not. No way. Now there it is. Yeah, a bit high, but there's the top of the fourth degree polynomial. Or is this the top? It's 1/3 or something. Yeah, this is the top. Okay, what is this blue arrow doing here? I forgot what blue means even. Oh, it's a drop. So jump point was here, and then when we actually measure it, we drop down to there. So that was an old one. Why was that still here? Try this again. There's also here one. So now we jump here, so the blue arrow should move there. And it doesn't. one's also wrong. It sets a draw point on this cubic. But really we're jumping to the maximum of this 4th degree polynomial. So it should have been pointing there. I'm coding in C++, as you can see. This is in handle local something, local extreme. And then after fitting the polynomial, and then we figure out where the best 0 is. And then we use it. And expected W is, I think, the y value, of course, yeah. It's y value of the 4th degree approximation. So this is what I should be using when drawing that point. I've got that point called, well, let's go there. Or let's maybe first look for another W. Expected, yeah, I'm gonna use that expected thing, I think. Yeah, I think this is the problem here. This should be expected LW. Just follow the green arrow. We have the green arrow here, and this is the draw point. We jump here, and then there's no blue arrow. But okay, the next green arrow is okay. Again, okay. See, now it points to the right place. We jump to this point here. And then we go up, and that should be a blue arrow that starts here, but it's overwritten or something. Overwritten by the black line. It's not very useful. Yeah, it was overwritten. There should be an arrow here. I thought it was off screen, but started here. Yeah, you can see it. The green arrow points to this point, and then we drop to the real function. So now it says it's going to drop here. I guess that's just because there is no extreme. Let's see, next prop is minus 54, so that would be here indeed. And the reason is that it is random generated. What the hell? Randomly generated, because it's the first time it appears here. Where does this value come from? No, just a step to the left. So there is no other usable extreme. And why is that? Oh, right. Yeah. 4-3 polynomial has what does you think is yours? Man, why is there so little debug output? All the information I want is not there. Well, it must be one of these, I guess. No. No. That's just what I use to fit it. Oh well, I'll just believe it. Yep. Well, I think that there's a red arrow here underneath the green one, which is annoying that we can't see that. But what can you do? Before I go to bed, I want to fix that one. As per the description. Though I'm not happy that the blue one is still broken, it seems, but well, let's do that another time. think the red arrow should be like here, pointing to the left, being the first sample that I measured. So 0, which is erased in the meantime. I restart and then I put my mouse on it. So it should be there. Should be an arrow here instead of there. What I'm doing currently in this function is initializing right node and left node to be left and right of the left, and yeah, nodes are known points that we measured, as it were, and left and right is then the node left and right of this value here, which might not exist if this value is like further to one side than the nodes that we have. Then yeah, there's no node on that side, so we then we only find one. It should never happen that both are end, actually. I mean that the chain is empty. I am going to add that back because really I think the code, I'm not sure the code would work in that case. But on the other hand, it's just, dude, why would you ever call this if the chain is empty? Just said, okay, not going to add. This was hard to write, but at the end we have a reasonable start. But it depends on which one is assigned, depends on the direction. So here I'm switching first on the extreme type, and then on the direction. So if the direction is right, I assign right off. If the direction is not right, then it is left, and then we assign left off. And then here I do that again. So again, if it is right, we assign right off. So it would be nicer, I think, if I turn that around. I put this on the outside. Is that possible? Should be possible. Let's commit it first, though. So let's say I want to have this test first. It's definitely going to be problematic with my comments and stuff. without this assert under comments, it would be easier. I guess I'll just remove it. Okay. How to do this? Let's do it a long way. I just make small changes while the code keeps working. So currently I have an else here, but I'm gonna get rid of the else. Here we have if next extreme equals maximum, and then else means that it is not maximum but minimum. So I can replace the else with if it is equal to a minimum. Then I think we can do this simply twice. Let's see, so I want to just not do this else, but stop. And then do that again. And then here do the else of this thing. Which means that now this must be not right, but left. Yeah. I mean, there was an else here. Instead of the else, I just check if this is left. That would be the else then. And this is the same as that one. Doesn't change much. And then we can do the same here. So I'm gonna copy this on. And then this else is actually the opposite of that one. So now you have left off, right off, left off, right off, but they are all separated. So now I can swap those two blocks. Put right off together. And the left off too, of course. Also, this is now an if with another if. So that is just an AND, and we can just swap them. Yeah, I mean, once you get here, then both are true. So it doesn't matter in which order you test them. Same thing here. And here. And here. And now I can combine them, because this says if left, and then here again is left. So there's no need to do that. You can just delete this. And that's all just H direction equals left. Same thing here. This is if it is right, then we do this, and then this is also right, so you can just delete it, all of this. And then we can change this one back into an else, I guess, because this is now equal maximum, and then yeah, if it's not a maximum, then it is a minimum. So if it is a maximum, if it's not a maximum, it will be a minimum. So I might as well do that. But then again, now I have all the right of assignments here together. And I'm assigning a left node here and there. Wouldn't it be nicer if I just had one line saying that assign a left node to it? How could I do that? Well, that is the case if I guess I have to do the same trick as before, and now combine the right of equals left node with the right of equals left node with an else, and then it doesn't matter. Whatever test we get, you can just delete everything, because that means if blah blah blah, right of is left node, else right of is left node. And then I would have just one of those lines. Ah, no, that's the same trick. How to do that? Yep, well, I'm afraid I have to go back then to having that. As well as you have to get rid of this else. So I need to do that and then negate it. So not all of that. Yeah. No, hopefully it works. Maybe I should have saved in between, but I feel that it is going to work. So do the same thing here. And then duplicate this if again. Duplicate this if. And then I can move this up here. Let me do this part first, or I forgot what I did. Duplicate this to remove the else, negate this one. Yeah, it's not really working out the way I want it. Maybe partially. Let's just continue. I don't see it yet, but basically I'm repeating the same trick as before, and that one worked. So now we'd have to swap these two, because they're not just ended. Boolean end. So might as well swap them. And then I guess I have to do that everywhere. So it wouldn't be super nice if this was the same thing, but it's not. However, it is, because I'm saying something really weird now, but it kind of is. I mean, if I replace this with next extreme type, and next extreme type equals maximum, then the code didn't change. While that means that this would be executed in exactly the same way if next extreme equals maximum. And if next extreme type is minimum, then this if changes, so that would either be now no longer true or no longer false, I don't care. Well, no longer true or still true, I mean. But this would fail anyway, so we would never execute this. So it doesn't really matter if this one is then false. Well, otherwise it was true. In other words, we can short circuit these two by putting next extreme type here. And the same story holds for this. I can just put next extreme type here, because nothing happens if it isn't. And then again here. And here. then now these two lines are exactly the same. This one and this one. Yep, so I can remove this and put it in the same block. Ah, it works. Ha ha ha. Collapse, bitch. Oh, like this. This is the same, right? Again. Yep. So this can be deleted. These two are not the same, so this can be deleted. And these are the same. Great, great, great. Now, and then what I said, if it is not a maximum, it's a minimum. Therefore, this is an else. And we do the same thing in both cases. So we might as well delete everything and just be left with left off is right, left note. Ha 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 ha. Now again here. This is now an else, so everything is gone. Yep, same here. Holy collapse. Also, this is the negation of this whole thing. It's not right node equals n or has extreme order, left node type next extreme type right. This is an else. Same thing here. No, I'm happy. Could make this into what is it? The tertiary operator thing? Question mark colon. But the line doesn't get much shorter, I think, because it hardly fits on one line. I do it anyway. What do you mean, Rudra? My voice is not deep. My voice is not so deep. What are you talking about, man? Question mark? Let's put the question mark here. Man, this was one of the better streams I've done in a long time. It is just this last part. I had like 2 pages of code and it collapsed into this with some use of magic. Now it would be nice if now after this collapse the code would make also so much sense that I can understand that it is correct this way. So I think the argumentation here is that if the direction is towards the right, then what we want to force is that the thing that we are searching for is on the right of something. Later on I'm going to add an to the left of something. Let's see, how many viewers do we have? 5. Okay, I'll explain in more detail what I'm doing here. Kind of after the fact, but please compile. I could have just run it. It does not compile. Never mind. I left it semicolon in. This plays a role. Yeah, maybe I should draw it on the drawing side instead. It's not very easy to show it here either. Let's find back the drawing side again, which of course I forgot. What's that side? I deleted the top and then I thought, I can remember that. Free drawing. Whatever. Yeah, canva.com. That was it. So the idea is as follows. We have a series of points. We make them red. So let's say these points are measured. We don't know what the function is. but it looks like a parabola, right? Now we determine that this one is a maximum. Hey, if it is a parabola, then it's kind of logical that that is the maximum. And then after finding this maximum, I want to find a minimum, and well, not this minimum, but this minimum. Yeah, so we know not just that this is the maximum that we just found, but also that we want to go to that side. However, now it is possible that this point wasn't exactly where the maximum is, but it's like on this side, for example. The cubic, we fit the cubic through points because we know the derivative as well. And the cubic that fits through this is having a maximum there. Oh. And then this one is going, exactly like through that point. It looks like a straight line now, but you get the idea. There's a cubic through these the points, and the maximum is there. Now, it could be that the cubic fitted through these 2 points is like this. Because, why not? If the derivative here is upwards, then, the parabola was not true. And the cubic fitted through these 2 points could be like, I don't know, something up and then down, and then we get up at, I don't know, like this. It's hard to make them look like cubics, I have to admit, but it could go wrong there, but maybe these are the cubics. In this case, I want to find this minimum, by the way, not that one. So we find a point on the left and on the right of that extreme. And now I have to decide if I want to set my right from here or there. Now you would ask, why the hell would I ever put it there? Because I miss this minimum. So yeah, in this case, we want to set it here. So we will find this minimum. But it could have been that we had the following case. Let's say we had this point and we have this point. And the cubic looks like this, I think. This is a cubic, don't ask. In that case, well, we want to search there, so now I cannot put it here. If I would do that, I would find this minimum here. And that is not what I want. I wanted to find it to the right of this maximum that we found. That's the real thing. I just can't put these things on a vertical point here. I can only put them on the red points. So in this case, we must put it here. Otherwise, we would find that point. Okay. But yeah, as you can see, if the direction is to the right, then my limitations are also pointing right, obviously, never left. And it's just a question, do we want to put it on the point on this side or on the point on that side? There is a special case also, by the way, that we don't have any points. Let me just erase this. It's possible that this is the last point. There is no point on that side. In that case, I just always set it on the last point. I'm not going to set it here, because I know that the cubic fitting through these two predict a minimum, a maximum here. So there is no maximum here, but there could be a minimum here. If you understand what I mean. A cubic has either nothing, or it has a minimum and a maximum, either this way or the other way. So if you fit a cubic and it has a maximum here, then it does not have a maximum here. So either this is monotonically rising, otherwise you would never have a maximum on this side, or there is a minimum here. So it could also be something like this, and now we have a minimum here. So we never want to find this minimum, we want to find a minimum on the right of this extreme. So we are never going to do this, because that would either work or find the wrong minimum. It would work in this case, of course, because then there is no minimum here. So if there is no data point on that side, then I'm just going to say on the right of that one. Now, of course, it can still go wrong if actually the curve would look like, let's say, so we have this and we have this point, and it predicts a maximum here. That is the prediction. I'm going to say, okay, I'm going to look for a minimum on that side from this point on, then I will find this minimum. But the actual curve could look like yeah, so well, no, sorry, it's not even necessary. I just could fuck us up. Let's see if I do that. No, the maximum must be here, otherwise. I mean, we found this maximum as per algorithm, and then I have to admit, then I have to assume that that's actually there. There must be a maximum there, but it's just, I mean, theoretically it's possible that there is a minimum here and then there's a maximum there, and I'm just oblivious of it. But yeah, okay, then if we start here, then we might find that minimum, and then I'm happy actually, but then we miss this maximum. I don't know, it's just not gonna happen, I think. It's just one of those edge cases that I have to ignore. Okay, so then we go to the code. So with that in mind, is this code now logical? So this is logical, that if the horizontal direction is right, then we have to set right off. If it is not right, it will be left, and then we have to set left off. That's just a mirror. Okay, if right node is chain end, that means that it doesn't exist. So the left node is this one, and the right node does not exist. It means that right node will be set to end. Then we must set it to left node, like I just said. Just the node on the left of this extreme. So if right node equals end, or I don't care, then use the left node. And yeah, this is just mirrored. I mean, you don't even have to look at this. If that works, then this one works as well. Suppose just left and right swapped. Left right swapped here, left right swapped here, and left right swapped here. If right node is not chain end, then we set it to left node or right node, depending on the result of this function. which means that this type has the order such that this extreme is on the right of the other extreme. So if this thing is maximum, then this will return true. If the maximum is on the right of the minimum. Now I need my erased stuff. So for example, in this case, we have left node and right node. In this case, the next extreme type is a minimum. That is the thing that we're going to find. We want to find a minimum. So this one is a maximum. Then the next extreme type is going to minimum. This minimum is on the right of the maximum in this thing. So this is true. Correct. The minimum is on the right of the maximum. So this is true. So then we use left node. And that's correct, because we want to find this minimum. If we would have put it on the right node, then we would have missed this minimum. Of course, then we look on that side. While if it is the other way around, so we have something that looks like this, maybe. I need my Mac, so yeah, that's difficult. But let's say we have something like this, then. No, exactly that. So. Seems unlikely that with just these 2 points you find that one, but hey, it's possible. I think it's possible. Theoretically, it's possible. Let's put it that way. So now I don't want to do to the right of that point, because then we would find this minimum again. You know, we should already have found it if we found this one and we are going to the right. So in this case, we want to put it there. So yeah, now in this case, the minimum is on the left of the maximum. So this will return false. And then we pick the right node. So looks like it works. Also, if there is, if the cubic does not have both a maximum and a minimum, then this is always going to return false. So if it does not have both, then it means that we have, well, we have 2 points. Let me add a point back. You have 2 points, and we have the maximum. Here's the maximum, and there is only a maximum. There is no minimum in between. Well, in that case, there is no, that doesn't really matter where you put it actually. Because we're looking for a minimum, so it's safe to put it here, but you might as well put it there because you won't miss it. So this is going to return false, and we always pick the right node. Well, this one then. No, why not? So that works too. Now in the meantime, it got damn late while I wanted to finish this function. Because after having done this, these are just at the kickoff. Now we have an initial value. What I want to do next is move this point further to the right. For example, we are looking for a minimum. Let's clean something up. So it was there, not here. Now we're looking for a minimum, and we just have some simple data points. It's not complicated yet. And the cubics between those look like expected. These are just cubic fits, not the real function, but they fit so nicely they're almost on top of the function every time. Then of course we see that, well, we had this initial right of that point. And we see that the type of this cubic is monotonically going down. That means that it doesn't have a minimum, so we might as well move there. And on this one, it's exactly the same type, so move it there, and then exactly the same type, so we move it here. And then the type of this one is that it has a minimum somewhere in the middle. So we don't move it there, and we stop. Yeah, more complicated possibilities exist. I have a shitload of possible types. Let's go to the code. As you can see here, these are all the possibilities. Well, there's even more of them, but this is the function. These are all the types that exist. So we have flat, up, down, so we just saw a lot of downs. Then you have something that just keeps going up, keeps going down. Oh, sorry, also keeps going up, but on the other to the other side. This one is starting flat and then going up, going down and then flat. So if we would see this, then we already passed the minimum. Yeah, we kind of started with something that is like a maximum in this case. So we would never suddenly see that one. This one can only follow one that ends on an underscore like that. So we'd always find something that ends on an underscore before we see this one. So we're not going to approach that one. This would be possible, but then we stop because yeah, it has a minimum, even though completely on the edge. It's kind of is a minimum. I might as well stop there and actually use that point. This could be the very first one. If we are in the maximum, we just want to pass this one. This should never happen. Here we want to stop because it has a minimum or ends on a minimum at least. So either we are not going to encounter it or we stop because the thing has a minimum. And if it has a minimum on the end, then we might as well use that. So maybe I'm firstly interested in things where we just really have to set the right off and then stop. That would be the cases where the function has an unfound minimum, like this one. So this one is going down and then afterwards going up. So that corresponds with this one. Here it's going down and then here it's going up, so there must be a minimum in between. Could also be this one though, theoretically. But it should have been the very first one, immediately here. So if this point exists and those points, those 4 do not exist, then you, well, and this was a red point, then you would have this. Starts horizontal and then goes down and then goes up, and then we are there. So in this case, yeah, also stop here, stop here. This can't happen, but I don't care then, because it's just not going to encounter it. This can't happen, this can't happen, this can't happen. So it's quite limited. So now let's look for the, sorry, I'll read the chat. Can you explain what you're doing with the project? And I don't have time for that. Credit Center approximates a point using iteration. Yeah, I do. I use 2D at the moment, and I'm not using gradient descent anymore. I'm just trying to come up with an algorithm that quickly finds a minimum, global minimum in a function. And then I will apply it, we'll try to apply it to multiple dimensions and neural networks, machine learning, but yeah. Okay, so, oh yes, it's impossible to work on this without the visualization. I mean, this is drawn, but I mean, I have a test suit. I'll just run this test suit here. Blob. So it draws exactly what is happening. 4th degree polynomial derivative. The derivative of the derivative is not visible. We jump here because that's the maximum of the 4th degree polynomial that fits this the group here. Then we find this maximum, and then we find this minimum. This minimum is higher than that minimum, so now I jump back here. And then we go to the left because we already were here. Stuff like that. Is visualization enough? Loads and loads of arrows and functions and yeah, Cairo window. Yeah, it's the project. Sorry, so Cairo graphics. I'm using X11 directly, or yeah, just X11 and libcairo. It's the front end, of course. So the Cairo window project is almost finished. It's pretty powerful now. You can just use it and then do stuff like this. I mean, it's really powerful, much more powerful than you might think. For mathematical purposes. I don't know, to just show one. So you can have a slider, you can have you can drag points, which you can restrict to, for example, on a circle, as you can see. And it is super fast, of course. So this draws a cubic Bezier through draggable points. There's a better, I have better programs in the meantime, but you get the point. And then you can do this in a mathematical sense, you know, like you can just it's in C++, but you more or less type like, I want to draw a line from this point through that point. Or it must be perpendicular to some point. Yeah, I do it without being paid. So if I'm having fun, nah, I'm having fun. So I'm doing for fun. Let's see. I think I'm not going to finish my objective for today, as usual. I probably should separate these anyway then. And now add code here and here separately, because in this case I want to advance right off to the right and here left off to the left with a simple loop. So it's kind of what do I do here? Very interesting, but no. Yeah, so I want to do something like while condition advance right off. Well, I have a better advance here. I'll use standard next, but why not just increment? A right off is iterated to a standard list. I definitely do not want to increment it if right off is the end of that list. Worse, I don't want to increment it if it is not allowed to become the end of the list. So right off is not the end when we start, and I don't want to increment it if the next node is the end. So something is unequal end, and that something is I just forgot the name. So I have sample node. Next sample here, that one. It's not allowed to be end. So that would be next sample then. So while the next sample is not end and certain condition, then we advance it. Now I'm from the Netherlands. I tried Kitty in the distant past, but I switch back, I guess. Is Kitty also true color? However many bits that means for the color. Because I need that for my syntax highlighting. This is, you know, true color as in color picker, and you can just pick whatever color you want. Okay, when do we want to increment it? We want to increment it as long as I do not encounter a cubic that has the extreme that we're looking for. And then I mean an unfound extreme. So it could be this one, then we want to stop. If we were looking for a minimum, well, if you're looking for a maximum as well, but then it wouldn't happen. The first extreme here is a minimum, but yeah, I don't see it, so it's a part of it. Let's say we have something like this with the part that I highlight. It just ends on it. Do I want to increment it in? I could increment it in, but then immediately afterwards I want to stop. I'm not sure I want to deal with that in this construct. So I probably should break this loop as soon as we see any minimum. So something like has extreme next extreme type. Has that extreme. If it has that extreme, then we want to well, then we don't want to continue. So there must be a not. Yeah. And now I still have to write that function, apparently. Maybe, yeah, well, this is going to be a member function of sample node. It's the only downside of my system is that I have to type sample node in order to jump to it. If it's not on my screen, but well. So we have the type here, and then if the type contains a certain extreme type. You can just get the type and then test it. But yeah, I have an is rising and is falling. Yes, unfound extreme. Aha. So it's something like this, but this is for unfound. So I just have to add as extreme, and then we test also the found extremes at the end. Boring. Return. Yeah, lots of C++20, man. So we can do this faster. But I try to stop worrying about speed in advance. It's difficult enough as it is. With faster I mean that I convert the integer that I pass as extreme type to the bit mask here, and then just test that. Yeah. Oh, you have that has minimum. I have an has minimum and has maximum for a given cubic to next sample type, and that tests indeed everything. So this already exists. It should now work. Now I might as well add this one as well then. And then test it and then go to back. No, I never tried Emacs. Okay, let's see. We're going to the left, I guess. So this now must be no, mine is left off. When do we not want to decrement it? Well, if it is begin. That's it. If it is equal to begin, it is still valid. But after decrementing, it would not be valid anymore. So that's kind of the same thing as that test. So I'm willing to decrement it all the way to the beginning, to the first element of the list. All the way on the left, far left, it's okay. But we want to stop if the extreme type that we're looking for is in the cubic on the left, which is now not this, because the cubic on the left is not cannot be accessed like this. I have to do standard previews. And then I'm wondering if I cannot combine this with that. The point is, of course, that if this is false, then we don't increment it. So if we do the pre-increment here, sorry, the pre-decrement here, and it fails, then I have to increment it again. I can't just do it in the end, because if this fails, then I don't have to increment it. I wonder if the compiler is smart enough to just store this in a temporary and then use it here instead of decrementing it twice. No, yeah, it's good enough. Even if it's going to read the link again, the link of the standard list to the previous element, and that is obviously still in the fastest cache. Okay. Now test and 2-bit. Bah, that's not how I wanted to test this. I'm calling next sample on something that doesn't have a cubic. Yeah, okay, it just doesn't let me. It could have returned end for an example, but it doesn't. It wants that this is true. It is debatable. Can just remove the assert and then we get end probably, but I'm not even sure. So if we want to follow this, and I cannot do that, so instead I could just test this directly. Haha, that would work too. So let's do that. So I want to test that it has a cubic. And I forgot again. Sample node. That's just this type. It must have that type. How do I figure that one out? Can just call that. So that's just asserting on it. Can almost call nothing. Do I have just something in here that looks like the same? No, I don't. Okay, then try it again. Kadung, 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 kadung. Okay, there it is. Run, 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 run. Yep. Yes, it works. So this arrow here is now the first point. So first the arrow was here, but now it just says, yeah, it is going up and up and up and up. So might as well do look for a maximum on the left of this point. And there is no other point on this here, so yeah, we couldn't advance further. And immediately it sets a red arrow here. That's a bit quick. Yeah, I suppose it's kind of logical. I mean, even if this was not, this is green even, so now it's found extreme. The local, it just jumps exactly on top of the extreme. But even if it did not do that, then still, maybe it would be interesting to jump a little bit past the point. What would happen then? Oh yeah, if we jump past it, then it should point the other way, and this one should still be there. I want to try that, just to see that. Then we have to run till point 11 or something. 11 is also here. Let you enjoy it too. So that is what happened. This thing stayed, and that one stayed as well. And only then it finds that this is a local extreme. All is good. Yep, we find that it is a local extreme. It's kind of silly, yeah. So wasted CPU. They'll never go in the other direction. That went. Just put on top of 12. Which is, might not be the exact extreme. I have to zoom in on the top. But yeah, I think everything is kind of works these days. Since today, I mean. I'm gonna commit this and go to bed. Okay, good night.